So we've been talking about how f and f inverse are diagonal flips of each other when we look at the pictures. And diagonally flipping, well, happens to swap the x and y coordinates. So what's really going on is if you have a function f of x, which is 1 to 1, then the inverse function f inverse of x is a related function. They are not the same function. They're just related to each other. How are they related to each other? Well, in terms of a picture, they're related by a diagonal flip. Let's say some other things about how these are related to each other. So between these two functions, f as well as f inverse, the domain of one of these functions is the range of the other function, right? So the domain of f is the range of f inverse, and the domain of f inverse is the range of f. Also, between the function f and its inverse, the inputs of one become the outputs of the other, and that's because the roles of x and y swap, right? The x and y swap if you diagonally flip the picture. Also, between the function f and its inverse, if you compose the two, and in either order, you just get back x. So that is f of f inverse of x is equal to x, and f inverse of f of x is also equal to x. By the way, let's talk through some notation that sometimes people try to do. You'll notice the notation up here, f inverse of x. Yeah, this -1 thingy, please say inverse when you see that. And it's written before the of x. It's not written after. Okay, this when people do this, they're really confusing what's actually going on here. And it's that f as well as f inverse are both the names of functions. So this -1 does not belong here. It's part of the name of the function. So it should be f inverse of x. Yeah, write it this way, not like this. Also, if you see f inverse of x, and it's probably part of the problem of this kind of thing, sometimes people think this means a reciprocal, as if this is 1 over f of x. It does not mean that at all. Instead, f inverse of x is the inverse function. Now let's just review a key matter from last time. This is meant to reinforce the idea of what swapping x's and y's, that a function and its inverse involve a swapping of x and y. So first of all, let's just replace the f of x with a y. And now let's swap the x's and y's. So instead of y equals 5x over x minus 6, we swap. Everywhere there was an x, there's a y. Everywhere there was a y, there's an x. So now we have x is equal to 5y over y minus 6. Now we need to solve for y. Well, this is an equation with a fraction, so to solve for y, multiply both sides by the LCD. In this case, since there's only one fraction, the LCD is just the denominator of the one fraction. You multiply both sides by y minus 6. So you have x times the quantity y minus 6 is equal to 5y. Distribute the x, so xy minus 6x is equal to 5y. Let's have all terms with y on one side. How about on the left side? So subtract 5y on both sides, add 6x on both sides, factor out a y on the left side. So you have y times the quantity x minus 5 is equal to 6x. One last step to solve for y, we just need to divide both sides by what's in parentheses. So if y is equal to 6x over x minus 5. Now we just replace the y, since we've earlier swapped x's and y's, now that y is called an f inverse of x. So there's the inverse function. It is f inverse of x equals 6x over x minus 5. Now let's follow up this question with another related question. Let's take the same function, f of x equals 5x over x minus 6. If I go back, that was the same function at the beginning of the previous question. And let's find the domain and range of this function. So first of all, the domain of this function f, we need to avoid when x minus 6 equals 0, or we need to avoid when x equals 6. And so the domain of f is all reals except 6. So negative infinity comma 6 parentheses, union parenthesis 6 comma infinity parenthesis. Okay, that's the domain of this function. What about the range of this function? Well, that'll be the domain of the inverse function. And we just previously computed the inverse function. The inverse function is f inverse of x equals 6x over x minus 5. So let's find the domain of f inverse by avoiding the denominator here, x minus 5 being 0. So we need to avoid x equals 5. So the domain of f inverse is all reals except 5. So parenthesis negative infinity comma 5 parenthesis union parenthesis 5 comma infinity. So since that's the domain of f inverse, that's also the range of f.